we're back with another really cool show and tell. This time, Pavel from Quantco is going to present his work on the S3 support in Pixi. And welcome, Pavel. Thanks again for doing another presentation with us. And hopefully, we're going to learn some new things today. This is live streamed on YouTube so we can watch it back later. And enjoy. And thanks for coming.
Yeah, hi everybody. I'm Pavel. Quick words about me. I've worked on Pixi for also quite some time now. Started on with the project, I think, right when it became it got the first hype. I also joined in. I'm working at Quantco since now almost 3 years. And before that, I studied mathematics and computer science in Karlsruhe, Germany. And at Quantco, I'm mostly doing like software engineering and data engineering as well. Okay, so we are talking about S3 in Pixi today. But before we actually do that, let's quickly dive in how to actually like host public and private Conda packages. So, for example, imagine you want to, you have a package and want to let other people use that package. For this, if it's an open source package, you usually create a feedstock for this. This is handled usually in Conda Forge, where we have a lot of packages, different packages that are built there in CI. And basically what you can then do is with Pixi or with other Conda tools like Conda or Microrumba, you can then download and install these packages. Conda Forge itself and BioConda, they are mainly hosted on anaconda.org, but there are also mirrors available, for example, on prefix.dev or on GitHub Container Registry, for example, as well. And prefix.dev actually also supports newer features like sharded repo data, for example. So that's basically how to host public Conda packages. But now imagine you are working inside of a corporate environment and your coworker has developed a Conda package that I want to use. Now the question is basically, how can I distribute my Conda packages to my colleagues with everything in mind that a corporate setup needs? So basically there are multiple options. Let's quickly do a market overview of what types of options there are. So, for example, there's prefix-dev. You could create a private prefix.dev channel. The advantage of that is it's very, very easy to set up. And prefix.dev also supports tokenless authentication using OpenID Connect, for example, for uploading. Prefix.dev also has like some other very nice features like package signing. And it also integrates very well with Pixi. The prefix.dev guys are developing Pixi and also prefix.dev itself, so it integrates nicely, obviously. The disadvantage of using a private prefix.dev channel is that you don't really have any control where packages are stored, since it's basically on their servers and you don't have any say in where it is actually stored. On prefix.dev, there are more features planned eventually, for example, an on-prem solution or a hosted solution on AWS, for example. And Wolf also told me that you're planning CVE scanning as well at some point. Another option would be Quetz, for example. That's a product or a tool from the Mamba organization. It is a free and open source tool that basically allows you to also host your Conda packages on a web server. It has some nice features like SSO support, but since it's an open source project, there is no real pre-hosted solution anywhere. So that might be annoying for some people. And also one disadvantage is a bit that it uses self-built authentication. And as you hopefully already all know, is that authentication you usually should not self-build, but use pre-existing libraries. Another option, more enterprisey, would be Artifactory. So yeah, Artifactory is an enterprise product that comes with some advantages like thorough testing, and Artifactory itself is also basically the de facto standard for hosting any types of artifacts and packages. So not only Conda, but also things like npm, PyPI are all basically possible in Artifactory. They also have some other nice features like remote channels, so you basically can mirror things like Conda Forge in your corporate environment, or also virtual channels, and like any other enterprise product, it obviously also supports single sign-on. It has some disadvantages though, namely being an enterprise product again, it's not open source, it's actually like quite expensive as well in some scenarios. And also, like, if you come to an issue, at least from my experience, there is potentially kind of a long waiting time for these issues. And also the pricing in some scenarios also scales with usage. So if you are hosting, or if you are actually like downloading quite a lot of Conda packages, or maybe a lot of large Conda packages as well, then that might be extra expensive for you. Yes, and now actually the topic of this showcase, S3 buckets are also now supported by Pixi. Actually, S3 buckets also have been supported by Pixi, or by Conda actually, for quite a long time, not by Micromamba or Mamba, and now it has found its way also into Pixi. So S3 buckets, I mean, quickly, what is an S3 bucket? It's basically an open standard implemented by many cloud providers. It was started by AWS as like a standard to host files in some way in the web or in the cloud. And that basically, since it was like an easy to use and nice standard, many other cloud providers adopted that standard as well. So for example, there is Cloudflare R2. You can also host your own S3 compatible API using MinIO. You can also use Backblaze B2, Hetzner, the German cloud provider. Also, just recently created their own blob storage, so they are all basically S3 compatible. What's nice about this solution is that the authentication is already done through the S3 protocol, and we can be sort of certain that that S3 is actually, sort of secure in comparison to, for example, like if you build it yourself in some way. And also, what's a very nice thing in my opinion is that S3 is a bare bones and universal solution. So basically, in any environment, you are very likely able to get some S3 compatible bucket in some way, and that heavily decreases vendor lock-in. So you can basically very easily also host your packages now with S3 inside of any corporate environments or any other difficult to host environments. So let's actually quickly take a look at what actually a Conda server or a Conda channel is. A Conda channel is basically just a collection of files hosted on some arbitrary web server. So, for example, here, if I host my packages on mycondaserver.com in the subpath channel, then basically, if I specify that in my Pixi toml, Pixi will then just take a look at what do we have in the noarch directory. Do we have like a noarch/repo.data.json? That's basically the a file that contains all of the metadata for all of the packages. So, for example, the versions, the names that we have, and all of the packages that we have, and also their dependencies and all of that stuff. And basically, Pixi, if you install a package, then Pixi can basically just downloads these files and unpacks them on your system. The authentication can be either done with no authentication, so for example, Conda Forge on prefix.dev or on anaconda.org. Doesn't have any authentication since it's the public channel, but you can also have authentication via, for example, HTTP basic auth or using bearer token. That's, for example, what prefix.dev is doing, and Artifactory also supports bearer token. Or a Conda token, it's like another authentication concept that's mainly used by Quetz and by anaconda.org, for example. So that's basically how a Conda channel, a regular Conda channel via HTTP looks like. And an S3 Conda channel is basically very similar. It's basically we just replace the HTTP with an S3:// and then we also have all of our Conda packages in the noarch and our other platform directories, and we also have the repo data JSONs. So it's conceptually very, very similar to a regular Conda channel, but just in another S3 bucket. And the authentication here is done via the typical S3 credentials that we all know and use from AWS or other cloud providers. Yes, so let's take a look at how we would actually set that up in Pixi. So basically very, very simple. We just add the S3 bucket in our channels. We just type in S3:/ and then the path to our bucket and channel. And then we can also, like for this bucket, we can manually configure the S3 options. So for example, if you don't use the default AWS setup, you can say, okay, like this S3 bucket should use this S3 endpoint and is located in this S3 region and is using the path style or not. So that's why, like in S3 internal implementation, AWS doesn't use path style, but most other cloud providers do use the path style. It's basically just where the S3 buckets are located and how you can use it. And uploading packages to S3, like we just only took a look at how we can download packages and use it in our Pixi toml, but to actually use it, you also need some way of uploading the packages there. You could, for example, for S3, just use any S3 client that you want. So for example, MinIO or AWS CLI, but also actually Rattler build, so the other larger tool that prefix.dev built that builds Conda packages, also can upload Conda packages, namely to S3, anaconda.org, also Artifactory, and yes, some other channels as well, I think. And you see here the command that's actually used for this is pretty simple. You just type in Rattler build upload, and then specify the channel and all of the other S3 options that you need, and then you basically just give it all of your Conda files that you want to upload, and then it just puts them onto your S3 bucket. And also now you basically, since I already mentioned, an S3 bucket is like a file system just in the network. This repo data JSON that I mentioned earlier, this needs to be dynamically generated each time the packages that you have in your channel get updated. And for this, we also built another tool called Rattler Index. This basically just reads all of the packages that there are in your channel and then creates a new repo data.json and uploads that as well to your channel. And this ensures that Pixi always has the most up-to-date package versions available and when it reads your repo data. Then let's actually take a look at a quick walkthrough / example on how to set up Pixi support using Cloudflare R2, since Cloudflare R2 is actually like a quite cheap S3 compatible API and storage API. It's much, much cheaper than the original AWS S3. And what's also interesting is Cloudflare R2 actually has free egress in comparison to most cloud providers. That means that it doesn't really matter how much outgoing traffic you have. It's always free. So you only pay for the storage actually. So for example, if you were to host Conda Forge on there, it would probably cost like something around 200 euros per month for this, for all of the 20 terabytes of storage that you need to allocate. But you don't need to pay anything for additional web traffic. Okay, so we basically start off by opening the Cloudflare dashboard. There is like on the top left in the sidebar, you can select R2 object storage. There you click on create bucket. Then you basically are presented your bucket that you want to use. There you can specify a custom bucket name. Then you click on create bucket on the top bottom right. And then you basically can see your bucket settings. And in that, you actually see this S3 API thing here. This is basically the endpoint URL that I showed earlier in the Pixi toml example. And then you basically go back to your R2 object storage overview and click on the API button here. and click on Manage API Tokens. And then you basically get created, shown this page here where you can actually like create an S3 access key pair. And you can specify that it should only have access to this specific bucket, for example. And then you basically get your access key ID, secret access key, and can then run Pixi auth login with these credentials to your bucket, and then basically just use this bucket in your Pixi toml. And that's basically from 0 to 100 how to get Cloudflare with S3. How to get Pixi support in Cloudflare. Okay, another thing. You can not only use Cloudflare R2, but also AWS S3. Pixi also has support for some more advanced AWS features, for example, like single sign-on. So, for example, if you have your own custom aws.config file, where you specify your account ID and also like your SSO URL, then you can actually like run AWS SSO login. Then it logs in via AWS. You need to click a button, I think, in your browser, and then it basically saves your credentials in some magic location that AWS knows. And Pixi also knows that magic location and reads the credentials from there and can then install your packages using AWS authentication as well. And this authentication you can also actually do in GitHub Actions, so you can use the AWS action that basically download or create your access keys temporary for authenticating to your S3 bucket using, for example, OIDC, and then you can basically directly use that within Pixi as well. That's been it. Thanks all for listening, and are there any questions?
Thank you, Pavel. That was very interesting. If nobody else has a question already, then I would like to ask one. Mainly, do you know if there's already support for the sharded repo data in the Rattler index? And
No,
then
not
for
yet.
the S3 buckets?
So Rattler index currently, like the version that's like right now out right now, only creates a repo data.json. But I'm planning to add support in for Rattler data, repo data.json.set standard, and also the sharded repo data, and also actually repo data patches as well.
Cool.
Repo data patches I've currently implemented. There's a PR open that I'm waiting for Wolf to review, and the rest is coming after that.
Yeah, cool. I believe there is no real difference between S3 sharded repo data features apart from the HTTPS, right? It's all the same.
Yeah, should be quite similar to the regular one.
Cool. Anyone else has questions for Pavel? I believe you built it with the whole team, and the whole team is also here, right?
Yeah, I built it together with Moritz and Daniel.
Yeah, thanks guys for these kind of extra features. Greatly improves the usability of all of our tools in this case, actually. So it's great. Thank you.
Actually, one thing that I didn't completely get is if you regenerate the repo data JSON, do you have to do that manually now?
Currently, so my thoughts about that are you basically set up a cron job, and that regenerates the repo data JSON like every time or every, I don't know, half an hour, for example. And it basically just does an ls on the no arch or on your subdirectories and sees if there are new .conda files that are not already in the repo data JSON, and then would read these. So it's also not really that cost intensive.
Yeah, sounds good.
Great. Then if there's no more questions, I want to thank Pavel again and the team working on the features. And I think this is a great example of how you can use all of the new features coming from S3. Also, thanks for showing how you could set it up yourself. That will be very beneficial for people coming in that want to try it out themselves. And looking forward to the next features you're going to build for Pixi.
Thanks a lot.
Thanks for the
Yeah,
presentation.
the stream has ended.